Vectors are actually a relatively new invention, and there's no one answer to how they came about, but here's just an idea that I think kind of makes sense. So when we're learning about numbers on the number line, what we're usually told is to think about it as kind of like jumping to certain positions. So for example, if you think about 2 plus 1, that means you go to the point 2, which is over here. So one thing you could do is you could think about that as an arrow. So it's like an arrow going over to 2. And then when you add 1, you can think 1 as an arrow pointing this direction, and then doing 2 plus 1 is the effect of kind of following both of these arrows. So if we follow the arrow to 2, that ends us up here, and then the arrow to 1 tells us to go 1 unit to the right, so we end up here on 3. And that's kind of one way of thinking about how the number line works and how addition works, and basically how vector addition works is just when we expand this to 2 dimensions. So in this case, the arrows are now in 2 dimensions. The red arrow represents go 3 to the right and go 2 units up, and the green arrow represents go 3 units down and 1 unit to the right. So then if we add these vectors, is what they're called, then what ends up happening is that we basically just follow what each one does. So the red arrow tells us to go 3 units to the right and 2 up, so that makes us end up here. And then the green arrow tells us to go down by 3 units and move 1 unit to the right. So we go down by 3 units, 1, 2, 3, so we're down here, move 1 unit to the right, and we're over here. So the result of adding the 2 vectors is we end up at this point here, and this point ends up being, if we read it off, it's 4 units to the left, and it's 1 unit down. So this is our resultant vector, which is what happens when we add the other 2 vectors. In this sense, we can kind of think of vectors as actions. So the red vector is basically telling us to move from the bottom of the vector to the top of the vector, and the green arrow is basically telling us to move from the bottom of the vector to the top of the vector. So what happens when we add them is we do them in succession. So we move from the bottom of the red vector to the top of the red vector, and then once we're here, we want to move from the bottom of the green vector to the top of the green vector. So what it would help to do is if we can move this green vector to the top of this red vector. So as I said, here what I've done is I've moved a copy of the green vector to the top of the red vector, and as you can see, that shows us visually what we did, which is that we moved down 3 and 1 to the right. So basically, if we check what happens when we go from the tail to the top, and then the tail of the green one, when we move to this position, because after we follow the red vector, we're already here. And then we have to say, what happens when we're already here and then we follow the green vector? Well, the way that we can visualize that is by moving the green vector on top, and the green vector tells us to move down, and the result of that is basically moving to this white vector. And because addition is commutative in the real numbers, so that means that if you have like a plus b, that's the same as b plus a, we could have done it the other way as well. We could have first followed the tail of the green vector to the tip of the green vector, and then we could have done the red vector. The red vector says move 3 to the right and move 2 up. So if we're down here and we move 3 to the right and 2 up, you can see we end up at the white vector, which is what we said was the resultant vector. So it's the exact same thing, and I can copy a copy of the red vector down, and you'll see that. So you can see that whether we follow the red vector and then the green vector, or follow the green vector then the red vector, we end up in the same position. So if this red vector is called A, and this green vector is called B, well then this white vector is what happens when you do A and then you add it to B. So this is how we add vectors, and we could have done it the other way, because if we did the green one and then the red one, we end up in the same spot, so you could also call the white vector B plus A. What you might notice here is that we formed a parallelogram because we took copies of these 2 arrows. They're parallel to each other, of course, and then we did the same with the green arrows, so this forms a parallelogram. So when we're adding vectors, sometimes teachers will talk about the parallelogram law for adding vectors, and this is why it works. In fact, you don't actually have to draw an entire parallelogram, you can just draw 2 parts of it. The reason for that is because remember that we were able to do this either way, and the part down here was showing us one way of doing it, and the part up here was showing us another way of doing it. So in reality, we don't have to draw a parallelogram. All we have to do is bring one of the vectors to the tip of the other vector, and then see where it lands, which in this case is here. So we don't have to draw an entire parallelogram, we just have to draw a copy of one of the vectors onto the tip of the first one, and that'll show us what happens when we do both of the vectors in a row, in which case we end up here. It's also important to understand that vectors aren't necessarily arrows, they could be anything, they could be functions, but this is just a geometric interpretation of an introduction to vectors and why we add them in this way.